So base rule, then maximum a posteriori hypothesis, which is the maximum of probability of D given H into probability of H. When the probability of H can be assumed as constant, then maximum likelihood hypothesis will come. That is probability of D given H maximum. Then brute force map learning is the probability of H given D is 1 by version space, number of version space, magnitude. Then maximum likelihood, minimum of target value minus the hypothesis value whole square. That is the minimum. Of course, the summation will come here. Summation of all those things will come here. Then optimal classifier is, if you want to classify, then the probability of the target value, here Vj may be either positive or negative if it is a binary classification, given Hi into the probability of Hi given D. Then we came to naive Bayes classification. Naive Bayes is equal to argmax probability of Vj. Vj is output value, plus or minus or plate NEs or didn't plate NEs, into the product of probability of attribute given the target value. So these are the basic knowledge that we should have. And then we defined yesterday conditional independence, a term called conditional independence. Conditional independence. So here we are talking about two events, A and B. Both are conditionally independent to each other, but they both may depend on the third event, C. So yesterday we considered event A coming to college by bike. Event B coming to college by college bus. Now these are independent, because when you go on bike, you may stop somewhere, have some tea or something like that. When you are in bus may stop for somebody. They are both, A and B are independent. That means the probability of A and B together is the probability of A into the probability of B. If they are dependent on each other, what will happen? Probability of A given B into probability of A given B into probability of A. Is that same equal to probability of B given A into probability? So if they are dependent, but here they are independent. But both of them, both A and B or dependent on one another event C. Maybe what is C? Traffic jam. Maybe due to some political rally or some accident, traffic jam. So, A depends on C, B depends on C. But the thing is, the occurrence of A given C doesn't give any information about the occurrence of B. Similarly, the occurrence of B doesn't give any information about the occurrence of C. A. Then this A and B are called conditionally independent given C. So here we mathematically said there are two events A and B, conditionally independent of third event C. If the occurrence of A and occurrence B are independent, completely independent, దీనికి దానికి సంబంధం లేదు, but given C, the knowledge of A occurs will provide no information about the B occurring, and knowledge of B doesn't provide any information about the likelihood of A. Then we call them as conditionally independent given C. So here we write the probability of A and B given C is the probability of A given C and probability of B given C. This is called conditional independence. Conditional independence. Now, why I am discussing this conditional independence? Because we are talking about Bayesian belief networks, which are also called Bayesian networks. Bayesian belief networks or Bayesian networks are graphical representation of the probabilistic picture. For example, I may represent a situation like this. Somebody, Siddhartha, sings a song. Em paatlu ishtam? This is an event. Goes to a movie. Are they related to each other? They are completely independent. But goes to movie may depend on have money. When he goes to movie, he may buy a Coke or popcorn. When he has money, he may go to a restaurant. When he goes to restaurant, he may eat biryani. After biryani, he may eat an ice cream. So, the probability, suppose if I call this as A, this as B, this as C, this as D, this as E, this as F. The probability of occurring all these events will depend on the probability of A into the probability of B, because B is dependent on A, the probability of C is dependent on B in turn A, into the probability of D given A, the probability of E given D and A, into the probability of F given E, D, A. Here this arrow mark indicates the dependence. Arrow mark indicates the dependence. Now see it technically. It is a directed acyclic graph, DAG. It's a directed acyclic graph. Acyclic means not cycle. It will not come back again. It is a directed graph that that indicates a condition. Now see the equation here. The occurrence of the events, probability of y1, y2, yn, so on, is the summation of, product of, what is the product? Probability of yi given the parents of yi. That's what we have written here, right? That's what we have written here. That's what we have written here. The probability of occurring all the events y1, y2, yn is the product of all the probabilities yi given the parents of yi. Here, goes to a movie has a parent, have many. Coke has a parent. Restaurant, goes to restaurant has a parent. Biryani, eating biryani has a parent. Eating ice cream has a parent. But have money? No parent. Have money? No parent. So, here the network is represented by using a directed acyclic graph, and we will have a probability table that we will see in short moment. Is it clear? What is that equation means? The probability of occurring all the events together is the product of probability of yi given the parents, given occurrence of parent, because it depends on you go to a movie will depend on whether you have money. If you go to movie, then only you will may drink Coke, maybe 20 rupees Coke outside, you may drink it for 200 rupees in the multiplex. That occurs because of that event. But have money, we didn't represent it here. So now, let us take a problem. Let us take what is this I am discussing? Bayesian belief networks, which is also known as Bayesian network. There is a famous problem in our textbook also. There is a problem, I will come to it later, but there is a more famous problem. There is a house. There is a house. In that person, he goes to office every day, and maybe he installed some alarm, maybe CC camera like that. But mana problem lo, let us assume that it is an alarm. So he installed, listen carefully, after that you can write, alarm he installed. This alarm will ring, will go off if somebody tries to steal anything from the house. If somebody breaks into house, burglary, if there is any theft in the house, that may go off. And similarly, even if there is no burglary, if there is some mild earthquake, also the alarm goes off. So here, the probability of burglary is 0.001, and the probability of earthquake is 0.002. Even if alarm rings, what is the use? He will not be at the home. He is at the office. So what he has done is, he asked his neighbors. One neighbor is named John. If that alarm sound John hears, he will make a phone call to that person. Because we cannot rely completely on a single person, he also asked another neighbor called Mary to call. But there is a problem. Sometimes John, he puts a loud music, so he may miss the alarm. There is a chance. Mary, she has some other sounds. Even if alarm doesn't ring, she sometimes assumes that alarm has rung. So here the probability when the alarm rings, the probability that John calls, when the alarm rings is 0.9. This is conditional independence. The probability that Mary calls given the alarm .7. and the probability that alarm rings when alarm rings, ఎప్పుడు వస్తుంది అలారం? ఎప్పుడు మోగుతుంది? either burglary or earthquake. So the probability of alarm given the burglary is 0.94. The probability of alarm given the earthquake is 0.29, and the probability that alarm rings both burglary as well as earthquake is 0.95. Sometimes alarm goes off even if there is no burglary, even if there is no earthquake also. Sometimes దానికదే మోగుతుంది, మనం ఏం చెప్పలేము. We cannot tell because no instrument in the world is perfect. So sometimes no burglary, no earthquake, but alarm goes. That probability is 0.001. Of course, that probability will be very, very less. This is the given data. So let us analyze mathematically the situation here. Let us come to the equations. The first question is from the given data, calculate the probability what is the probability of burglary happening given that both Mary and John calls ఇద్దరు ఫోన్ చేశారు, both have called. So is it 100% sure that if both have called there is burglary only? When they call, when they hear the alarm, Sometimes loud music, he may miss the alarm. Sometimes other sound, he may assume it as alarm. And alarm may be raised because of the earthquake also. So here the question is, given that Mary called, the question is, what is the probability of burglary given that John called and Mary called? Is my question clear? Both have called. What is the chance of burglary? So we will derive a similar thing. How many events we have here in this problem? And totally we have 5 events. But in the question, 3 events. Now let us come here. The probability of 3 events occurring is the probability of burglary occurring, both have called John and Mary, into the probability of John and Mary both calling. In other words, the probability of burglary given that John and Mary called is the probability of all the events occurring together by the probability of John and Mary calling. Here, probability of John and Mary calling is a prior probability, is a constant. Is prior probability and it is a constant. Let us call it alpha, 1 by alpha. 1 by alpha. So now, the probability of burglary occurring given that John and Mary both called is 1 by probability of John and Mary is some constant alpha, we will calculate it later, into the probability of burglary, John calls, Mary calls. But when they call, when they call, alarm ring. When the alarm rings, earthquake occurs. So, this I will explain. The sigma of alarm and alarm positive, alarm negative. The probability of sigma of what is another event? Earthquake. Probability of B, J, M, alarm, earthquake. I will explain it, don't worry. Right. So, what is, apply the chain rule. What is the chain rule? The probability of occurrence of y1 to yn is the product of probability of yi given parents of yi. Now, when you see the diagram, you will understand who are the parents and who are the child to which side. So now you tell me what is the probability of occurring all the events together. Tell me, which are the independent events? First we will write. No parents. No parents. Earthquake and so probability of B, no parent. Probability of all product only. All products into next probability of alarm given both the parents, then probability of J calls, when he calls alarm goes off, then the probability of Mary calls when the alarm goes off. So now the probability of burglary occurring given that John and Mary both calls is equal to alpha is a constant, sigma alarm, sigma earthquake, probability of B, probability of earthquake, probability of alarm ringing given that both burglary and earthquake occurs, probability that John calls, probability that Mary calls given the alarm. Which term we can take out of the sigma, both the sigmas? Which term, which probability has nothing to do with alarm and earthquake? Probability of independent of alarm and independent of earthquake. Burglary. So, alpha into probability of burglary, and let us write into which are the events triggered by alarm? The probability that J calls into the probability of Mary calls triggered by alarm, and this alarm is triggered by whom? Earthquake. Given burglary, and now what we will do is we will make a table of probabilities and we will just plug in those values there. We will continue it tomorrow.